So last time when we got together, we talked about 2.1 qualitative data, and qualitative data was data that described something, right? These are non-numerical terms. So like the color of a car or the weather pattern. Is it sunny or is it cloudy? Okay. And so we could collect this data sort of in a textual list that looks like this, but it's very hard to analyze that. So instead, what we created was something called the frequency chart or a frequency table, which basically counted the number of occurrences of each category and then organized them into a table. And so you could see that there were 12 Chevys from this table. It's a lot easier to see that information as a table rather than trying to find all the Chevys in this list. So this was the frequency. We also had another type of frequency that we wanted to talk about, which was the relative frequency. So relative frequency was the frequency value as a percent of the whole. And so you may say, okay, there's 12 Chevys, but is that a lot? If it's 12 out of 14 cars, yeah, that's a lot of Chevys. If it's 12 out of 1,400 cars, that's not a lot of Chevys. So we need to put this in some type of perspective. And so the relative frequency allows us to do that. And to calculate the relative frequency, you just take the raw frequency value and you divide it by the total number of items, which we found by adding them all up. And that will give you a decimal, 0.24. You convert that into a percent by multiplying by 100, and you get 24%. So almost 1 out of 4 cars are Chevys in this parking lot, okay? And so this is great. We have a frequency table. We have a relative frequency table, but still, we're dealing with tables and numbers and your brain doesn't like it that much. And so we decided to switch into a visual mode. And how can we represent this information visually? So we started out with the bar chart. And so what you do is you place each category along the x-axis, and you can switch these around. So we just kind of put Ford first and Chevy second, but we could have taken, put Chevy over here, right? Like we could have put the Chevy bar first if we wanted to. So there's not really a rhyme or reason. You just kind of put your categories in there. And then notice that the y-axis is the frequency, the number of times that each one occurs. So there are 5 Fords here and there are 12 Chevys here. So this is a nice way to display the information. We could also display the relative frequency, that percentage, as the same graph. And so if you look at the relative frequency, you'll notice that the y-axis changes to relative frequency. And these are now the percentages that we talked about. So this is actually 25%, that 0.025. This is 20%, 0.2. And so here you would have basically the same information. This would be 24% would be right there. This would be 10% right there. And so you'd be able to figure out the relative frequency from this graph. There's one more graph that we talked about, organizing a little bit better, would be a Pareto chart. And in a Pareto chart, what you do is you take the information from the bar graph and you organize it from greatest to least. So the very first categories are the most frequent, and the categories at the very end are the least frequent, okay? So this was great. Bar graphs are wonderful for displaying information, but the one thing that they lack is the ability to compare the data to the whole. And that's where circle graphs or pie charts come into play. And so here we have the category, Ford. We have its relative frequency, 10%. And then we also have the raw frequency, the 5 Fords, 12 Chevys, 6 Hondas. And this gives us a perspective. How does it visually relate to the whole? So you can see the number of Chevys here. It's about 1/4 of the circle. Like this is 1/4 of that pie wedge. And so this really starts to create a feeling for how does each category compare to the whole. Okay, so these are the two types of graphs that we really like to use with qualitative data. We like the Pareto chart or a bar chart, and then we also like the circle graph, okay? Graphs that you want to be aware of is when you take a circle graph or any graph and you pivot it, you make it 3 dimensions, and you create a perspective. So here are 2 graphs that represent the exact same type of data. Will you vote for candidate A? Will you vote for candidate A? In the first one, the yes votes are brought to the front and the no votes are pushed back towards the rear to make them appear smaller due to perspective. So it looks like there's a whole lot of yes votes because they're brought to the front and the wedge appears larger. And it appears like there's not that many no votes because they're pushed to the back and that wedge appears smaller. If you then flip it and you bring the no votes to the front, you can see that the perspective makes it look like there's a lot more no votes because it's closer to the front and it appears larger. The wedge appears larger, where the yes vote appears a little bit smaller because it's been pushed to the back. Okay. So be careful of perspective. Also be careful of pictographs that are maybe inappropriately used or incorrectly used, I should say, maybe not inappropriate, but incorrectly used. And so here you have the average female height per country, and they're using the entire female from toes to head as the icon. But it doesn't match the scale, right? So here at the 5 foot mark, you could see that women from Latvia are giants because their kneecaps are 5 feet tall. And women from India only measure up to the kneecaps of women from Latvia. It's just the scaling of this is just all wrong, right? And so there's a better way to represent this information. Also, be aware of icons that are being used. Here's sort of the same thing. The icon used for the banana is wider than the icon used for the apple, which is wider than the icon used for the cherry. So this table actually represents the same quantity of each fruit. There are 4 bananas, 4 apples, and 4 cherries. However, if you were to make a bar graph out of this, it looks like there's more bananas because they're farther out to the right when in fact they're the same amount. And so the icon that you use, the scaling of that icon can be misleading, just like the icons that are used here and the average female height are a little bit misleading. Like it makes it look like literally the women from India are only as tall as the kneecaps of women from Latvia, which is not the case. Okay, so be aware of these things.